Howdy. This is an impromptu stream because I didn't know whether or not the weather would cooperate, whether or not I would be awake or up to doing this. And so whoever sees this, sees this. So what am I doing other than checking my watch for, oh look, I got a YouTube notification that I'm live. Ain't that a kick? Anyway, what am I doing? Well, I'm sitting in the comfort of my own home, VNC'd into our observatory. Let me make sure that it's still there and functional. It appears to be. We'll get to that in a moment. I want to do something real quick. I want to just start that up. And, okay. I apologize in advance. I'm working at home with two very small screens, so it is difficult. It will be an interesting little experiment in terms of managing all of this. So, what are we going to be observing tonight? So, as I mentioned before, this is a partial lunar eclipse. What that means is that the moon is going to partially move through the Earth's shadow as the Earth orbits around the sun and the moon orbits around the Earth. This occurs during the full moon phase, and it can be seen by anyone who has the opportunity to see the full moon at the current time. So people on my side of the hemisphere, the western part of the hemisphere, I would go to say great, but really it starts at 1 and will end at 4 in the morning for us. So it's not exactly great, but it is better than, say, 24 hours from now, which in friend of mine, Jeff in Vietnam, he will not be able to see this at all. So one of the reasons why I was planning on doing this and recording it was just to more of proof of concept and to give folks a little bit of a view of what was going on. Who might not ordinarily have been able to catch it. So what are we going to actually see? And so what I'm going to try to do here is share one of my screens. What we see over here is a simulation using Stellarium, which is a free program. You can actually has a web browser based. If I were more sophisticated, I would put a link to Stellarium in the chat. Actually, I think I can make a comment. Let's see. It's real hard. It's called stellarium.com. You go there, and there are two options. You can download the software and load it locally on your machine, or there's a web-based version which you can use as well. Either one of them, great piece of software. It allows you to set your location and a whole slew of other things to allow you to see various things in the night sky. Like, for example, the moon. Now, I'm going to zoom in a little bit, and I'm going to double-click to make sure that it stays in the center. And what you can see is, if you noticed, that the upper half or upper left-hand side of the moon is darker, or seems to be darker than the lower right. That's not just a consequence of the fact that the upper left is dominated by mare or lava plains or ancient impact craters on the surface of the moon. But it's also because the moon is currently going into or in the penumbra of the Earth's shadow. Now, there are two parts of a shadow. Traditionally, we really don't see these or encounter these because of the fact that our size scales are much smaller. But if you were to say, look at the shadow of a very tall building. Hey, Sydney. If you were to look at the shadow of a very tall building over a very long space of time, you would notice that there's this sort of, what's the word I'm looking for? Lighter shadow that precedes the darker shadow. And so this is, the darkness up there is actually the penumbra of the Earth's shadow. And so in approximately 4 minutes, in the upper portion of the moon, we should start seeing a little bit of the moon decreasing, like so. or getting darker. Like 2. I'm speeding up time because I have that power with this program. And so that was very quick. I'm going to back that up a bit because I was prepared for how quickly that would go. So we're going to see this sort of in reverse. And that is essentially how how it's going to play out. And we'll revisit this in a moment because I'm pretty sure those of you who want to see this are more interested in looking at what the telescope can actually see. So let me stop that. And actually, let's see, can I do this? I think I can do that. Waha. Oops, nope. I apologize for that. I don't know why it's doing that. Let me see. Much better. No idea why that was happening. So what we can see here is an actual view of the moon as we are seeing it right now. Now, unfortunately, the way I've got, and I'll be playing with the orientation of the moon pretty much ongoing from this. But our field of view with this telescope coupled with this CCD camera or digital camera, this field of view is 25 arc minutes squared. To give you an impression of scale, the full moon, which is what we're looking at right now, is 30 arc minutes squared. So we can almost kind of barely see the full surface of the moon. If you notice, the moon just seemed to shift slightly. Now, there's a reason for that. Our tracking is pretty good. I've done a number of nights trying to get this, doing pointing models, trying to get our pointing and tracking as smooth and as possible. But the moon does not track at the same rate as the stars. The stars move across the sky at what we refer to as the sidereal rate, or I believe it's Latin for sidereal is Latin for star. And so the stars in the sky move at a particular rate, which is dictated by the rotation of the Earth. Planets, the moon, sun, all have their own, well, excuse me, the moon and the planets have their own motions, their own peculiar motions. And so they do not track along with the rest of these stars in the night sky. And so they will, if you are tracking on the stars, they will move ever so slightly with respect to those background stars, depending on the difference in speeds. With the moon, it's pretty noticeable. Now, what we're looking at is we're looking at a heavily filtered image of the moon in what we refer to as the ultraviolet filter. The reason why I'm using the ultraviolet filter is because it is what I'm doing is just trying to cut out as much light as you possibly can, because the full moon is, as you might expect, is pretty bright. It's a pretty bright object when you go outside and look at it. Through a 32-inch telescope, it's a ridiculously bright object. I wouldn't go so far as to say it would actually damage your eye if you were to look at it through an eyepiece, but it's not recommended. You're certainly not going to be able to see very well after looking at a full moon through an eyepiece with our telescope. It's just your night vision is just going to be completely fuzzed. So I need to block out most of that light in order for us to actually see what we're looking for. And I do that by using different pieces of glass, which I can rotate in and out of the field of view. And these pieces of glass will allow certain colors of light through. So one will allow only blue light through, one will only allow or green light through. Another one will only allow red light through. This one will only allow ultraviolet light. Normally, this is not light that we can see with our human eye, but the camera is sensitive to it, and so we can actually look at it. But the reason why I was talking about that is that the ultraviolet filter, since the moon isn't reflecting a whole lot of ultraviolet light to begin with, and because of the optical effects in the system, not a whole lot of light. About 75% of the light coming into the telescope is blocked out. So it allows me to get these nice crisp images of the moon. I'm actually really happy and really impressed with how well in focus it is. So yeah. What we can see on here, I'm eager to actually move it up. But before I do that, the really beautiful crater that I want to show, or that is on the surface, which I don't know if you can see you can see my cursor. Awesome. Which I'm circling here. This thing is the Tycho Crater, named after, or excuse me, Tycho Crater. I was corrected by a native Danish speaker that it's not Tycho Brahe, it's Tycho Brahe. If I'm mispronouncing that, if that person was wrong and I'm still mispronouncing it, I'm pretty much going to give up at that point. It's Tycho or bust at this point. But this is the Tycho Crater, named after the famed astronomer, the most brilliant naked eye astronomer that we had, whose observations led Kepler to determine or derive his fundamental laws of planetary motion. This is what we refer to as a rayed crater. So there are a couple of different things. So this is a tremendous impact. And so what happened is that you have a large rock slams into, probably a comet or maybe an asteroid, slammed into the surface of the moon. The moon became quickly molten because that rock exploded from the violent impact. Craters are not dug out like divots. They're literally explosions. They're bombs going off on the surfaces, or created via explosions on the surfaces of the world that you're dealing with. In this case, it was so violent that it exploded, and the crater, or the surface itself, became very molten for a significantly long period of time, at least geologically. Well, to what we would be considered a significantly long period of time. Astronomically, it was really a blink of an eye, but it became molten, and it created this crater-like shape, and then it rebounded. Like if you've ever seen a stop-motion video of a drop of water or a drop of milk falling into a glass, it will when it hits, it will cause the milk to bowl out, and then it will rise up and form this central peak. And that in a similar way, that is what is happening with the lunar surface, is that it bounces back up to a peak, and then it freezes over. And so the crater has a very high wall and a central peak to it. Now the rays, which aren't overly common, for if you were to look really at the surface of the moon, you can see that it's heavily cratered, and most of them do not have rays. But from this high up, in order to see craters, these craters are preferentially being created by large impactors or large explosions. And so they're going to preferentially have rays like this one up here, which I think is the Copernicus crater. And then you have these smaller ones down here with a couple of rays coming out, like this one down here. That is material that was thrown out. Those were what we refer to as debris or secondary impactors that was thrown out from that very violent explosion, throwing this material thousands of kilometers over the surface of the moon. And so just wanted to point that out before I start moving stuff around. Sydney, if you're there, if anyone happens to be there and I just don't know, if you have any questions, feel free to ask while I do stuff. I know, technical term. All right, stop this. All right. I always get this wrong, but I'm going to try anyway. Let's do 5 seconds at a time. All right. I want the moon to go to my bottom right. So that means I want to nudge the telescope to the upper left. And 5 seconds is not going to do it. Let's do 3 minutes. All right, now let's take a single exposure and see where we're at. The dark stains are, if I haven't already said this, are moire. Oh, that worked. All right. Let's do it again. These are ancient lava plains formed when the moon was exceedingly young, during an era which we refer to as the era of heavy bombardment, when the solar system was filled with hundreds of thousands, if not millions, of asteroids and comets slamming into the moon. Now, you might looking at this and say, "Oh, wow, the moon has changed dramatically." The only reason for that is because of this what we refer to as the screen stretch. Basically, what I've done is, because of moving the moon, I have moved part of the brighter portion of the moon off the image, and so it's rescaled the brightness. So this is nothing. The change between this to the other image has nothing to do with the eclipse itself. It is just simply because of the change in viewing. But hopefully you can see in the upper left, which I'm hoping to bring into better position. Hopefully you can see in the upper left, this is significantly darker. And I believe that is where the eclipse is going to begin happening. Let me play with this a little bit. So remember, this is a full moon. This can only happen, this can only happen during a full moon. So the moon is circular in shape. So any portion of the moon that seems to be missing or darker is because of the Earth's shadow that is passing over. Now I'm going to look up, I'm going to bring back the stellarium, and I'm going to check it out. Bring it back to this time of right now. Time date. So I think this is an hour off in terms of all right. Yes. Okay. I want to bring that to the right. So I want to go left. All right. I'm going to Hopefully you can see this. I can no longer see myself, so Again, I really wish I had more screens. In the upper portion of the moon, basically this portion over here, well, you can't see that yet, but so if you can see this, hopefully you can. You have this large mare here. You have this large mare here. You have this other smaller mare. If you draw a straight line through those, you get to where the side of the moon where the eclipse is happening. That's not what I wanted to do at all. All right. So there, and we can stop sharing that. And let's go back to sharing that. Oh, stop sharing. Oops. Eventually, I will get this right. Oh, hey, Ian. There we go. Sydney. I will be streaming for probably the next hour or so. I'm going to Green Bank Observatory tomorrow for a night's worth of observing with some students. So objectively, I probably shouldn't be up at this hour, but hey, why not? Oh, and please do call me Dr. Parks. I know that might sound silly, but I did do a lot to get it. So, Ian, need to go outside. Yes, it's not too cold. What, particularly if you're still in Baton Rouge. Now, if you're in Baton Rouge, go outside because I'm positive it's not cold out there. Anyway, what am I doing here? I am starting an exposure. So over here, you can see the small mare, the medium-sized mare, and the Papa Bear mare. You draw a straight line, and this is where Stellarium predicts where that eclipse is going to start coming in. And you can see that this edge is markedly darker than any of the other edges around it. And as we proceed, and I am going to do something else. I like to name things. Rob's Moon. We're going to do ultraviolet. We are not going to do 80-second exposures. One, apply, boom, and go. So what I'm doing now is I just set up a sequence of image, an autosave sequence of images that will basically, you'll just keep taking images over and over again at 1.1 seconds and saving those and taking up a whole lot of hard drive space. But I'm hoping that to be able to see something cool coming out of it. What I'm hoping to be able to do is, even in the hour or so that I plan on of doing these observations, what I'm hoping to be able to do is to be able to see some of that the terminator, the point. Well, terminator probably isn't the right word. The shadow, the edge of the shadow marking out the moon. And what I should probably do is, while the moon is really pretty to look at, what we're really interested in is in the upper left. I should stop that. Let me move this into, hey, Daniel from Charlottesville. I'm moving the portion that is in the eclipse more into the center of the field, or the center of the frame. So I want to start. And let's see. There we go. All right, now. So, yeah, the shadow, which is coming in here, again, you can see that it's not as pronounced as I was hoping it would be. But that, again, is probably because of the screen stretch. Hi, Barbara. Thanks for coming by. This is impromptu, so I don't know. I don't know whether I'm just going to be sitting here babbling, but I'm going to try to, for the next half hour to hour, I'm just going to have a continuous update of the moon. The shadow should be coming in here, in this area here. It should have. It technically technically started about 15 minutes ago. But considering that the overall eclipse is going to take, it's going to take about 6 hours, or give or take. This will probably be slow going. Barbara, I am a professor at George Mason University, and what you are seeing is the moon as seen through our telescope, our 32-inch telescope here in Fairfax, Virginia. And I am going to try to show a, what's the word I'm looking for? Real-time magnified view of the partial lunar eclipse that started around 1 and will be the hiatus. It won't be a total eclipse, but it will be the moon will be mostly eclipsed around 4 in the morning. And then unfortunately it's going to set where I'm at, and I'll miss it. But because I have to be up all night tomorrow, because I am going to West Virginia to a radio telescope there, I'm probably not going to stay up much past 2:30 or so tonight. So we will, and I'm going to be taking image, or just continually recording this, both through live stream and both through CCD images, just so I want to see whether or not I could maybe take this data and make a lab out of it. I don't know. We'll see. Where'd you go to school, Barbara? A 4.0 earthquake? I've lived through a 4.0. That was weird for a boy who's never lived in earthquake territory. That was something. Daniel, I do teach astronomy at Mason. I teach a variety of different courses, ranging from introductory to cosmology to right now I'm covering a observational techniques course. But yes, I do teach astronomy at George Mason. Not too exciting right now because, again, like I said, the eclipse is just technically starting, and so it's coming in on this edge here. Occasionally, I will stop this I will stop the telescope imaging and take the telescope imaging and to recenter the moon. Someone is clickbaiting. Oh, I'm sorry. I hope you apologize if you feel that way. That was not my intention in any way. So the moon, we can get into this. Oh, only one person is watching. Probably not Barbara. Yes, you are technically watching it. You are watching. It's very slow. As I said, the time between the time between the start of the eclipse and the midpoint of the eclipse is 3 hours. So, oh, 2 people, yay! Yeah, the live stream counter never seems to work. Thanks, David. Yeah, thank you for hanging out with me tonight while I do this. What was I going to say? If you, like I said, if you either of you have or anyone has any questions, feel free to put them in the chat, and I will try to address them. One of the questions I get is that I want to, when looking at the moon for public nights or something of that nature, is can you see the Apollo landers? And unfortunately, the answer is no. Right now, with this view, we can't. If I'm remembering correctly, all of the Apollo landing sites are within view of or are in our telescope view at the moment. I believe they are all around here in the Sea of Tranquility and the Sea of Serenity. Of course, my cursor is all in this area. I believe it's between these two mare. One of them is the Sea of Tranquility, which I believe is this one, and I believe this is Serenity, but I could be wrong about that. I have to admit my lunar geography or selenography is not as up to date as it could be. But unfortunately, no, we can't see we cannot see the lunar sites. There's no way for us to zoom in, as it were, to see those sites because there is a physical limitation as to what the telescope can resolve or make out based on its size. If you have a telescope our size, which is roughly a meter or so, then we can get down to maybe arc-second precision, arc-second resolution, meaning that we can. Yes, I knew that. You're right. I'm pretty positive Tranquility is the much larger of the two mare. One I'm uncertain of is if that is in fact Serenity on the right, on my left. But if you want to know what 1 arc-second looks like, or 1 arc-second resolution looks like, what you're looking at here is 25 arc-minutes squared. So take one basically row, or take this image, split it into 25 evenly spaced slices, and then take one of those slices and cut that into 60 equal space slices, and that's what we can get down to. And unfortunately, that is nowhere near the resolution required to be able to see the landers on the surface of the moon. I am going to readjust here in a second. I want to go that way, so that way. As I mentioned at the beginning of the stream, the reason why I'm constantly have to readjust this is because the telescope is tracking at a sidereal rate, meaning that it is tracking with the stars, sidereal being Latin for stars, I think. I don't know if it's Latin. I think it's Latin, not Greek. But the moon has its own peculiar velocity as it orbits around the Earth and as the Earth orbits around the sun. And so therefore the moon is going to be constantly shifting slowly as we go across. And so occasionally I will stop this and sidereal. Yeah, thank you. And I will reshift the moon, and so you can see it. Ah, Barbara's back. Welcome back, Barbara. All right. If anyone has any questions about astronomy in general, or about the telescope, please feel free to give me a shout out. Hi. Let's see here. Let me do something real quick. I'm going to publicize this to my students. Is the telescope located in Fairfax proper? Yes. So the downtown Fairfax, historical downtown Fairfax, is maybe 5 minutes from here, drive, maybe 15-20 minute walk. So light pollution of the places I've lived in with telescopes, this is fairly bad light pollution, but it could certainly be a whole lot worse. And Barbara, you have trivia? Oh yeah, sharing that screen, so you guys got to see that. All right. Yeah, like I said, I can tag. Yeah, so the best guy that I've personally had a telescope of this size, where I've had a good night, was I was a grad student at Georgia State, and there was their telescope, which is roughly around 24 inches, so slightly smaller than ours, or about a third as small as ours. It was in a state park, so the sky there did have a little bit of light pollution, but it was still in the middle of nowhere enough that the night sky was pretty nice. Not enough to see the Milky Way, but pretty nice. And then I did some work with a 20-inch telescope in Louisiana, in Baton Rouge, and the light pollution was worse. It's actually probably worse than it is here. But the humidity was god awful. Oh, good Lord. It was just really awful. Humidity here is surprisingly bad. When I first got into town, because I've only been in Fairfax for about 2 years now, but when I rolled into town, the person on the radio was like, "Yeah, it's going to be a humid one today. It's 60%." And I laughed at it. I was like, from where I come from, that's a nice day. That's a day to take a nice long walk outside. But I will say this: that there is a light pollution problem in that we're on campus, and there's two ginormous lights that are obviously meant to be decorative, that we really just want to take a BB gun and take care of. But I don't know. Sky around here in Charles is not terrible, especially compared to the area around IAD. Yep, I'm trying to figure out where IAD is, and hey, it's Jonathan. IAD is, and I have no idea. You'll have to give me an education for that. What is the farthest constellation from us? That's an interesting question. As it happens, all the constellations are just a 2D representation of the stars on a 3D sky. So you could you could state that all of the constellations are equally far away from us. Oh, Dulles International. I'm going to be picking up some vans from there tomorrow or today. But all of the constellations, as we see them, are projected onto I hate to use the word fake, but a reference celestial sphere. Now, the stars that we see in the sky are at much different distances. For example, if you looked at the Orion constellation, if you looked at the relative distances between the stars that make up the main body of Orion, then the distances between them, in this sense, from front to back, are about 1,000 light years. Well, I am not so as pessimistic as Barbara. The eclipse is in the upper left. If you look at the way to really imagine that is, yes, there is this dark stain, but there is you can see this grayer pattern here. If you go around the surface, then you notice that this is markedly darker than, say, the stuff over here. It's not nearly as distinct as, it's not like we're in the middle of the eclipse or anything like that, but it is, I would say, it's there. Actually, let me stop this. And I want to go that way. If you want to see like definitive eclipse action, I would step out around 3 in the morning. The highest of totality is around 4 in the morning. So depending on what your horizon looks like, I would probably step out around 3 or maybe 4. At 4 o'clock, it might, if you have a lot of trees near you, at 4 o'clock, it might be too low. But I am going to be sleeping by that point. Yeah, exactly. All right, let me do this actually. I'm going to go that way. So. Yeah, one of the harder things to control when doing this through with digital camera is the way that the camera will stretch the screen. There are only 255 channels for the telescope or for the camera to indicate changes in darkness. And so depending on how the moon is lit, it can affect how you see it in a digital image. So if I were to say actually move out and move the telescope so that this part of the Tycho crater is not visible, then that would change how this looks from a brightness perspective. But the way that but as I'm looking at this, I can tell just from my own experiences that and from looking at stellarium, that this is a little bit darker than it should be. But I don't think that we're really into the umbral part of the shadow yet. But let's find out. I'm going to do this. Ooh, Inception. Share screen. Hey, Kyle. So this is what this according to Stellarium, this is what the moon looked like, or the eclipse of the moon looked like 20 minutes ago. So let's this portion, I have a dartboard now. It's in my car, and I haven't had the time to actually bring it up and hang it in here. So if this is any indication, we should start seeing, well, I would say it should start really getting dark in the next 15 minutes or so. We'll see. Now I'm starting to get a little bit pessimistic about this, but we'll keep going. We'll go back to the other show. Let's remove that and then come back over here and share. There we go. Back to the action. Oh, that's it would help if I actually updated the image once or twice every so often. And yes, I am saving these because, you know, I like taking up hard drive space. So Kyle, you do realize that you just told me that you were out at the bar drinking, sorry, you were out at the bar throwing darts soberly the night before you go out to try to take data at Green Bay. Please tell me you were, oh yeah, you're not, I should know, Kyle is not driving because I'm going to be driving tomorrow. So, like, what is going on with me? I'll pretend I didn't see that, Kyle. I really wish this would have started earlier, but it is what it is. Kyle is one of my students in my observational techniques class, and he is looking at a particular type of object known as a blazar, which is a active galactic nuclei. And he has affectionately renamed the blazar that he was looking at the shrimp blazar. Which the data, surprisingly, not only does the blazar make up a constellation that looks shrimpish, the data could also be somewhat fit by a shrimp data, but who knows? That fit is surprisingly good for what it is. How long for what, Barbara? Yes, Kyle, the one that Kevin sent. All right. Let's do this. Where did I put this? I have no idea. Nope, that's not the one I want. Oh, yeah, it is. It's not quite this, quite the same scale. So let's try that again. Trying so that it's kind of apples to oranges at this point. Trying to get it so that we can compare the two. But no. Oh, Tucker. All right. Hi, Tucker. How long until it gets darker? That's what I'm trying to show now is whether or not whether or not we can see it if we look at old data. It's one of the things that one of the other reasons why I was recording this, or what I was taking repeated images, because I wanted to do something of a time lapse of the images, but I can't seem to find a good one. A good comparison. You should pull it up. Let's see here. What sort of work do I do normally? I'm assuming that was directed to me. I'm a professor, astronomy professor. My focus right now is teaching, although this semester has been a bit difficult on that end. But my previous research has been what's the word I'm looking for? In variability of objects, particularly young stellar objects. I'm very curious about how a sun's or a star's surface varies over its lifespan and over its overall lifespan, and even from day to day. So if I were to look at this, I would say, and I could be completely wrong, but the penumbra is about there, and the umbra is about here. Guess. if you stand on your head, maybe you can actually see it. I'm still going to try to find another image. There we go. There we go. There it is. Apples to apples. So that was near the beginning. That was about probably 45 minutes ago. Here's what the moon looked like at the start of the evening. Here's what it looks like now. To start. Nah, well, actually, whoops. That's not what I want to do. Let me do this. What's going on? Nope, that's not what I wanted to do. You'll see me at 1. Yes, actually, if people could arrive, I'd like to leave around. Well, no. See me at 1. Have a good night, Kyle. Get some sleep. Try not to be hungover tomorrow. Tucker, I don't know what post. I don't know what post. To which post you're referring. Oh wow, it's you definitely see that the edge here has gone away. All right, I'm going to stop this and then bring it over. Hey, how are you? Howdy. Come on, stop. There we go. All right, I want to take this down, so merge it. I am repositioning the moon so that the more interesting part, the eclipsing part, is more centered in the field of view. The image on the right is the image of the moon as it was taken right at the beginning of the night, right when I was really starting to get started. Now there you go. That is apples to apples. Now, probably not as overly impressive, but it definitely shows a difference in. Hopefully, you all can see that it's definitely getting darker in this area up here than it is over here. But to manage expectations, when looked at through a telescope, it's not going to completely disappear. The Earth's shadow, particularly in the sense of a partial eclipse, the Earth's shadow is not 100% dark. So the moon isn't going to be 100% gone. We're not going to see essentially part of the moon completely disappear. So, Tucker, I don't know what you mean by two people are clickbaiting. I am going to find it. I'm pretty sure that's Copernicus. Yeah, it's definitely a full moon today. What was I doing? go. Ah, there it is. I don't know if you can see it, but there is my nice app showing the moon. Of course. Aha, Matt. Yes. So that is Copernicus right there, and that is Kepler. These are the Apennine Mountains right here. If I remember correctly, Aristarchus is right there. Autoclitus and Aristillus are over here. I used to do the reason why I know that is I used to do a lab which had my students measure the heights and depths of mountain range or of mountains and craters the same way that Galileo did. Johnny, hey, Johnny has been slumming it a little bit. Can't sleep, and I hope it's not. I hope you will not be showing the full moon. Oh, I see, Tucker. All right, yeah, this is what the eclipse would look like. Is pretty much looks like right now. Yeah, with a house full of kids and a house full of dogs, I can imagine sleep is something that doesn't come by too quickly, or doesn't come by too easily. Yeah, I should be asleep because I'm going to be driving to West Virginia tomorrow. So, but I couldn't really pass up a chance to stream this. So I will probably only be streaming this for the next half hour or so. But that's the goal. For those of you who are maybe just signed on, the image on the right is an image of the moon I took right at the beginning of the night, and the one on the left is what I'm seeing right now. Better her than a certain doctor. No, I'm going to Green Bank, West Virginia, where the tied for the world's largest steerable radio telescope is. And so I'm not going to be using that one, but my students are going to be training on a 40-foot radio telescope. So, yeah, the Green Bank telescope is 100 meters in size. You can think of it as literally a football field that they are moving around in the sky. Oh yeah, of course I would know who Clarice is. Fava beans. But yeah, so I will be driving them tomorrow in less than 12 hours. So yes, science is better than sleep, or trumps sleep in a lot of cases. You got to be up for work in less than 4 hours. Good. Yeah. Can you sleep at work? Not that you should sleep at work, but can you? I'm hoping maybe I can catch a couple hours sleep before it gets, or after sunset, to when my students actually need to start taking data. But I doubt that's going to actually happen. That's what I think about my office. I need to have a cot and a pillow in my office particularly when I'm trying to stay up with students doing something like this, where they're at the telescope and using it for more academic purposes than what I'm doing. I always felt that a cot and a pillow would be. I've got the pillow. I do have a pillow in my office. I don't have a cot, sadly. Although, a quick trip to Walmart would fix that. Let's see what's going on with these images. I haven't been noticing the moon update in a while. Walmart? Yeah, back when things were wonderful. Oh, all right, there it is. It's moving. I was like, why is the moon not moving? The moon should be moving. Yeah, I don't know what it's going to be. I think it's going to be literally freezing on the mountain. I think tomorrow's forecast is going to be 32 as a low for tomorrow night. So should probably pack accordingly. So Johnny, who do you got? Who are you going to be talking about tomorrow on their Dingleberries on your show? You'll be talking about yourself? Nah. Nice. Nice. I unfortunately will be driving when that happens. So I will catch that on the flip side when I get back tomorrow. Because yeah, no internet tomorrow. No radio signals of any kind. No Wi-Fi. No cell reception. I'm hoping that they won't take my phone away from me when I get up there, because I would like to take pictures, but we'll see. I would really love to take video, but I don't know if they'll let me do that. Hey, who's controlling my screen? Someone is trying to hijack my screen. Ah! All right. Apparently, I need to end this because there are students at the telescope and they want to use it or something. So I'm going to. Oh, hold on. Let me send them a message. Let me stop sharing my screen while I do that. There we go. I think, yes, we are getting evicted, but I'm going to double check on that. Almost looks like there's a Blake up there. So actually, I am going to show this. So I think these are photo students. So you can see, oh, probably. You can see the telescope in the upper left. You can see in the bottom left, you can see where our telescope dome is. And then the bottom right camera is just allowing us to take a look at it. All right. Well, I wish I could get a hold of Tours channel. Stop sharing my screen. Dun, dun, dun. Okay. All right, all. I think that's a wrap. I did not expect anyone to be up on the roof, so I apologize for that. But thank you all for all of you who actually came and watched this with me. Like I said, this was fairly impromptu, so good night, everybody.